All right, so low code, pro code, why not both? So this is the agenda for this session. So we'll talk a little bit about why low code, and then we'll talk about why pro code. And then we definitely want to get into demos. So we're going to spend most of the time in demos. And then there's a nice little surprise here at the end for what's coming. So another little demo on something we're working on that I think you're all going to be interested in. So let's go ahead. Let's dive into it. All right, so why low code? Logic Apps is a low code platform, and there's a reason for that. We do want to democratize who can go ahead and build integration solutions. If we look back at history, we had BizTalk Server, and it is a very capable integration platform. However, it was not the easiest platform to learn. For you to become productive was generally taking some time. For you to become an expert was even longer. And Logic Apps was born out of the need to simplify building like workflows or integrations. And by making it simpler to use, it allows us to scale. By lowering the barrier of entry, including more people in the app building or the integration building experience. Now, how do we do that? We do that generally through drag and drop visual experiences. And the idea there is that it can, create a more welcoming experience for people to build these solutions, and for, experienced developers or more technical developers, it should accelerate the time it takes to build these solutions. And why do we feel that way? Well, really, we provide the plumbing, and we want you to focus on solving the business problem and not so much the underlying technical plumbing. So the ability to do logging, start and stop, exception handling, connectivity, security, things of that nature. And by providing a platform, we could standardize data access models through connectors, and we can also standardize security access models through connectors as well. And this should allow you to focus on solving the problem and not have to spend a whole lot of time on the actual plumbing. But we all know that there's going to be some limitations. Complex requirements can lead to complex solutions. And I like to look at this as the 80-20 rule, where low code can generally cater to like the 80% range. But then what do you do about the remaining 20%? And sometimes you hear the story of the remaining 20% is longer or more costly than the 80% it was. And that's where we feel we can help in this regard by offering some custom code extensibility. Now, why might you want to use custom code extensibility? There might be situations related to performance. So, for example, looping might be an example where you can execute those loops quicker inside of custom code. For some scenarios, maybe testability becomes easier in custom code, where you've got some logic and it's easier to sort of externalize that and then write assertions and test cases against it and provide more test coverage. And then there might be also scenarios around customer-specific IP, so intellectual property, where you want to be able to bundle this up and not expose the sort of raw underlying configuration to others. And so those might be all valid reasons for wanting to use some custom code. Now, historically, if we look at extensibility options, this is generally what it looks like, right? So we've got low-code platforms, we've got Logic Apps, and I would put Power Automate and Power Apps in that category as well. In the case of Power Automate, it runs on top of us. And we've got these pro code options, and these are just a handful of them. We've got writing a web API inside of App Service. Perhaps we expose an API through API management. We can write Azure Functions, or we can run microservices, inside of Kubernetes. Now, generally what that means is now you're hosting your code elsewhere, which means that you now need to deploy another resource, which means you pay for another resource, which also means you secure another resource, which means now you monitor another resource. Now, if you think about the traditional IT landscape, now you're talking about 3 to 5 or more copies of these resources. This complexity starts to add up, especially as you start to think of more and more solutions. So what's the option, or what's the alternative? So this is something that we did announce in October, mid-October, and this is .NET Framework custom code. And what this allows you to do is to write or author .NET Framework 4.7.2 custom code and call it from a built-in action. So when we say built-in action, we're talking about Azure Logic Apps standard here. If you have existing .NET Framework assemblies, perhaps you're doing a BizTalk migration, you have the opportunity to reference those assemblies inside of this model. And something that's particularly interesting, I think is actually pretty cool, is we create dynamic schema support for you, which means that when you go ahead and drag this, invoke a function in this logic app onto your canvas, we will automatically draw that card, that action card, to include any input parameters that you need to provide to that method. Similarly, from an output perspective, when you try to use the data that's returned from the custom code, we will also draw that dynamic content for you in those downstream actions. So this is going to feel very much like a connector, in arguably even a custom connector in some ways, that allows you to really use this much like you would any other connector action. Now, another interesting thing, and this was another advantage of using this type of approach, is we can perform debugging and debugging of our workflow and our custom code in the same VS Code session. Trying to do that with say functions and logic apps historically has been quite challenging. That is no longer the case. That is now very, very simple. We've also included application insights integration. So this was something that we added since the public preview. And so what this means is you can go ahead and write your basically like logging statements in your custom code. When you deploy that custom code to Azure, you're going to see those line entries sitting inside of App Insights, and you're going to see basically correlation IDs that will allow you to follow through your workflow actions to your custom code and then back to your workflow actions. So we basically follow the breadcrumbs, we stitch that all together for you. Now, general availability, as I said, was already this in October, so we've been just over a month. We've seen some great uptake of using this feature. And the number one question I do get is .NET Core, and when is that coming, or is that coming? And stay tuned to the end of the presentation. So let's just do a very sort of simple hello world onboarding experience, and I'll show you what's involved in getting this to work. Okay, so I'm in Visual Studio Code, and I'm going to take advantage of some of the new features that Wagner talked about, more specifically around the Azure Write and being able to load the backend runtimes, because I definitely need them when I use custom code, and that simplifies the process of getting this all running. So the first thing I'm going to do is I'm going to head over to the workspace, and we're going to use a workspace in this case because kind of what we have now is we're going to have a workflow project and we're going to have a code project, and we're going to use a workspace to kind of bind those two things together. So for those of you familiar with BizTalk and using Visual Studio and solutions with your custom code project and your orchestration projects, this is going to feel quite natural for you. So we're going to go ahead and create this new workspace. Then we're going to go through a wizard-like experience. We're going to just create a folder here first. We're going to be asked to provide a workspace name, so we're going to just call this AIS a demo. We need to provide a function name, so this is the name of the local function we're going to call. I'm just going to go ahead and call this get weather. And then we need a namespace, and let's go with our old favorite Contoso. Now, we also offer the ability to create a sample workflow template that you can go ahead and use, and you can go ahead and name this whatever you want. We'll open it in the current window. So now what's interesting is we've essentially created almost like a template for you that you can get started. Like, you should be able to get this working within 2 minutes. And from there, then you should be able to tweak it to meet your needs. So let's take a closer look at what's been deployed here. So here's our workspace. And then, we provided that name. Then we've got our functions project here. And then what we have is below it, what we do is we do create a sample, basically code file for you. And here's where we go ahead and use the inputs that you provided. So we've got the function name is called get weather. We just have like a very simple method that sort of demonstrates some of the capabilities. So you can have a typical .NET inputs here. It's like strings, integers, can be complex objects. Then we're going to go ahead and return a complex object as well. And so if we look below, here's our complex object. Here we just have some arbitrary logic just to demonstrate this. We do some calculations, and then we return the value. Now, the other thing that we provide for you is inside of the CS_proj file, we have some build tasks. Now, these build tasks are particularly important. So we want to keep the workflow project sort of pristine. We don't want to deploy source code to Azure. So what we do is we get you to compile your source code. We have this build tasks that you see here on the screen, and we're going to copy the outputs, the assemblies, into our Logic Apps project. We will subsequently then go ahead and deploy that Logic App project with the compiled assemblies to the Azure portal. So what we'll do here is we're going to create a new terminal, and we're going to do that in the context of our functions project. We can now go ahead and just issue a .NET restore command, followed by a .NET build. And when I hit the build action here, notice what's going to happen to my Logic App project. So what's been added here is we have a new folder called lib, and then a subfolder custom, and then net472. We've got our custom DLL, and then all of the other assemblies, the dependencies that come along with it. The other interesting thing that happens, and this is really important, is that we've got a folder that has the same name as our function, and it's going to create or include a metadata file called function.json. The built-in action is going to use this file, this metadata, to go ahead and actually draw the inputs for the built-in action. And then it's also going to use this data for dynamic content downstream. So when we go ahead and try to use the output, we're going to see that we've got this object that we can use that's going to have all of these different properties that can be used in other parts of our application. So what we can now do is go ahead and open up our designer. And when we open up the designer, this is that sample workflow that we include. We've got the function or the action already pre-populated. Here we can go ahead and click on this drop down. This is going to enumerate any of those function.json files that exist. And you can see here that it's determined we've got two different parameters. Now, these are hard-coded, but they don't have to be, right? We can feed dynamic content to them if we wish, and I'll show you that when we get to the Azure portal. So at this point, we're ready to go ahead and do some debugging. So what we're going to do is we're going to start with the Logic App debugger, and we're just going to hit the play button. This will take a few seconds. And we know we're in good shape when we see this, right? We can see that we've got our trigger loaded. We also have our function loaded there as well. Next up, we're going to go ahead and just load the debugger for our .NET code. This is quite quick. We can see that this number is incremented to 2, so that's already wired up. So let's go ahead. Let's set some breakpoints. So we've got our custom code. So let's just set a breakpoint here, just arbitrary, doesn't really matter. And then let's go to our workflow and set a breakpoint here. We can now go ahead and load our overview page. That's probably the easiest way to go ahead and call this. Once again, we know we're in good shape when we see this URL loaded and we see the run trigger button. So let's go ahead, let's click it. And what we should see is our workflow breakpoint gets hit. And we can now go ahead and use the typical commands that you would see, like your F10s, F5s to step over, step through, etc. The other nice thing we have here on our left-hand side is our local variables. So we can go ahead and use that information. Now, one thing just to make note of is here we've got that application insights integration. So here you can go ahead and use the logger. And basically we've modeled this after what the functions team has done in their samples. So if you're familiar with that paradigm, this will be quite familiar for you as well. Let's just go ahead and we'll hit F5 and jump through all of this. If we head back to our basically our output, we can go ahead and click on this and basically our run history and see the inputs and outputs. So what we'll do now is we're going to jump ahead, not there, to the Azure portal. So what does this look like inside of the Azure portal once it's been deployed? So let's head over to the Azure portal. Now, underneath the hood, for those of you that might be familiar with like a data mapper and basically schemas and maps, like we do have an artifacts folder. We've extended that to include assemblies as well. And so here's where we'll go ahead and see where our assemblies get deployed when you go ahead and deploy it into Azure. Now, if we head over to our workflow, we are going to see that same action is available, and we can go ahead and configure it. Now, naturally, when you author code in VS Code. But if you did deploy, a set of functions, up to Azure, you could go ahead and configure them from that perspective. So that's what that looks like. We can go ahead and call this or run this. And I'm just going to grab a very simple sample message here. We can go ahead and run with payload, paste in that message body, and sure enough, here's where the output is. The one thing worth showing you just in that designer, I have this response, and this response can go ahead and use those outputs. So here's like the entire function's output, but here's those individual properties as well. And so that just allows me to go ahead and use properties from a complex object in my output. So I think that's pretty cool as well. All right, so starting to get a little bit tight on time here. Let's just talk a little bit about application insights. So I did show you that log statement, right, from inside of the custom code. And what we can see here at the bottom is when we run this in the local debugger in the terminal, you're going to go ahead and see that log statement show up here in the terminal output. Now, where this also shows up is when we deploy it and we have application insights configured for our Logic app, that we're also going to see it in the traces table inside of App Insights. And here in the message property, we're going to go ahead and include that information. Now, how you sort of link all of these things together is through the operation ID. So if you went ahead and this basically is like the run ID for the actual workflow instance. If you go ahead and query the traces table where operation ID equals that value, we'll then return the custom code telemetry plus any of the workflow trigger and actions telemetry as well. So you really can go ahead and stitch all of this data together if that's something you're interested in. Now, the next thing, and this is where we start to get into, okay, so one more slide, then we get into the surprise. So I think the question actually becomes, okay, when should I use this versus when should I use some sort of external coding paradigm? And I think it really comes down to like the requirements that you have. I look at this kind of in two ways. You've got a centralized model, which is going to have pros and cons, and you've got a decentralized model, which also has pros and cons. So I think it really, needs to come down to your requirements. So if you want to have a centralized service, like you want to say expose a function and you want, say, many different applications to use it, including Logic Apps, then that would make sense in my mind to, provision an Azure function, offer it as a service, allow like other applications to reuse your code essentially. Now, the flip side of that is it's going to require more governance and coordination, and more specifically, dependencies, right? You have to now manage that. What if I make some changes? Am I going to break my clients? Then there's the decentralized model, and that's where you would have like your local function as part of your Logic app, basically what I just showed. And you can set this up in a pull model where you can still share that functionality, and perhaps you're using something like NuGet to go ahead and pull those common assemblies or libraries into your project, and then you can kind of use them. Now, the benefit is you do have fewer dependencies from that perspective because like the consumer is in control of basically the versioning. On the other hand, you do have some code proliferation. So, like I said, I think both models are acceptable, but just think through your requirements and choose which is the best model for you. All right. So, lastly, the surprise is, and I'm just going to let this play. If I can get this to play, is .NET Core is the the number one ask. And so that is something that we're working on. We are imminently about to release this in private preview. So if you like this idea of custom code, but you didn't want to use .NET Framework, you wanted to use something a little bit newer, this is the solution for you. And let me just rewind this a little bit. What we're doing to enable this is you're going to see the same onboarding experience that I just showed you. But the difference is you're going to have the option to choose whether you want .NET 6 versus .NET Framework. And based upon which one you choose, we're going to load the corresponding project for that framework version. We're also going to include the proper build scripts as well, so that when you are compiling your code, we're going to drop that into the right folder inside of the Logic App project itself. Now, I'll let this play a little bit. Now, the question is probably like, okay, why .NET 6? Where's .NET 8? So we will provide support for .NET 8. When we started to work on this this past summer, .NET 8 was still in preview. And so we didn't want to layer a preview on top of a preview. Now that .NET 8 is out, we will support .NET 8 in the near future. The benefit of like the model that we've built upon is that it is extensible, and we can now start to support other languages. If Function supports it, it's therefore something we can support quite easily. And so do share like what your needs are in this particular area, and we'll see what we can do. So that's kind of my presentation. I'm not sure if we have time for questions. Otherwise, I'll take a look inside of chat.